Imagine looking up at the sky and discovering something that doesn't belong to this solar system. A wandering intruder, traveling at an incredible speed, traversing the void between the stars. What secrets does an icy rock arriving from another galaxy hide? Tonight, I will tell you the story of 3I Atlas, the interstellar comet that defied everything we thought we knew about the cosmos. Why has it changed color after grazing the sun? And why are there images that NASA and other space agencies don't want to show? Stay until the end, because what you see could change the way you look at the universe forever. The story of 3I Atlas is a cosmic journey full of enigmas, a tale worthy of the best science fiction, yet so real that today we can observe it from Earth. It all began on July 1st, 2025, when the sensors of the Asteroid Terrestrial Impact Last Alert System Atlas telescope in Chile detected a faint smudge rapidly moving beyond the orbit of Mars. Within hours, astronomers realized that this object had an impossible trajectory. It wasn't orbiting the sun. It was shooting through everything as if it had come from the depths of the galaxy. Could this simply be just another comet? It quickly became clear that it was not. Initial orbital calculations confirmed that 3I Atlas was traveling on a hyperbolic orbit, a path so open that not even the sun's gravity would be able to retain it. It came from another star system, and after its fleeting visit, it would be ejected back into interstellar space, never to return.
From that moment on, the mysteries began to multiply. Its speed is astonishing. It exceeds 210,000 kilometers per hour, traveling at more than 60 kilometers every second. Perihelion, the point of closest approach to the Sun, occurred between October 29th and 30th, 2025, when the comet grazed 203 million kilometers from the star and was hidden behind its glare. But the surprise was immense when, after emerging from behind the sun, 3I Atlas appeared not only intact, but even brighter and more mysterious than astronomers had expected. The Discovery Telescope in Arizona was the first to capture an image of the comet after its reappearance, a faint, bluish smudge on the horizon, almost invisible to the human eye, but bursting with secrets for those who knew how to look. Astronomers like Qicheng Zhang felt the magnitude of that moment. It was only the third confirmed comet to arrive from outside the solar system, after Oumuamua and Borisov, but also the largest and most intriguing. Its nucleus, over 20 kilometers in diameter, with an estimated mass exceeding 33 billion tons, makes it a true interstellar behemoth. And yet, the mysteries had only just begun. 3I Atlas started displaying a blue color much more intense than that of the sun itself, contradicting the physical rules that govern the brightness of icy bodies in space. Avi Loeb of Harvard University said it bluntly: "If the comet is made of ice, it should be red and cold, but it is bluer than the sun. What could be causing this completely unexpected glow?" The confusion increased when a European team detected an anti-tail, a jet of dust and gas heading toward the sun instead of away from it. Some categorized it as a simple dynamic anomaly, but Loeb's speculation was even more provocative. What if it were a braking maneuver created by advanced technology? Imagine for a moment that the inexplicable has a reason that goes beyond nature. Although the majority of the scientific community dismisses that idea, no one can deny that we are facing a visitor with unprecedented properties, alien to the usual comets of the solar system.
Spectroscopic analyses have made it clear the chemical composition of 3I Atlas is unlike anything recorded before. A rich combination of water, carbon dioxide, cyanide, and nickel alloys never before observed in nature has been detected. The balance of elements, with a high amount of nickel and almost no iron, is baffling. To add to the astonishment, recent studies suggest the comet may have formed over 10 billion years ago, ejected from the oldest regions of the Milky Way, long before the formation of the Sun and Earth. All this matter, carefully preserved in a capsule of ice and dust, arrives in our system like a message in a bottle thrown into an unimaginably vast cosmic sea. Today, astronomers worldwide are preparing for 3I Atlas's closest approach to Earth. It will be 270 million kilometers away on December 19th. There is no risk to our planet, but there is the certainty that for a few days we will be able to observe in real time the material from which other stars, other worlds, and perhaps other forms of life were formed. And while science searches for answers, the concern remains. What other secrets does 3I Atlas conceal during its brief passage? Are we looking at a simple comet or tangible evidence of the rare wonders that our galaxy still hides? The mystery continues its journey, and this time it passes very close. With every new observation of 3I Atlas, the mystery deepens. The latest images captured by space probes and terrestrial telescopes show a comet that defies all the rules. An extremely compact nucleus, the total absence of the typical bright tail that comets should exhibit after their closest pass to the Sun, and a blue, almost alien luminosity that astonishes NASA, ESA, and CNSA alike. Astrophysicist Avi Loeb, famous for his bold proposals, insists that there are at least 9 anomalies detected in this intriguing visitor. Mass loss with no visible trace, inexplicable dynamic behaviors, materials like nickel alloy known only through industrial processes, and an age exceeding 10 billion years.
But the latest evidence, the detection of a hydroxyl radical, OH radio signal by the Meerkat Observatory in South Africa, seems to momentarily close the debate on possible artificial origins. The signal is consistent with what is expected from the chemical activity in a natural comet, just as it receives the bath of solar radiation. However, the fact remains, 3I Atlas does not behave like any comet investigated to date, and its anomalies, the anti-tail, the absence of dust, the intense blue glow, and that tireless journey from outside the solar system open the door to new questions. Could it be an authentic galactic time capsule, delivering matter and secrets from generations of stars that preceded our Sun? Or are we facing evidence of processes and phenomena still unknown in the far reaches of the galaxy? Stephen Hawking predicted it years ago. Interesting objects can carry unknown knowledge and elements, capable of challenging our species and rewriting cosmic history. In December, 3I Atlas will approach Earth at a safe but sufficient distance for dozens of observatories and thousands of amateurs to try to unravel its final mystery. Key data on 3I Atlas. 3I Atlas is the third confirmed interstellar object to visit our solar system, detected on July 1, 2025, by the Atlas system from Chile.
Trajectory and speed. Its hyperbolic trajectory and speed exceeding 210,000 kilometers per hour confirm that it originates from outside the solar system and will not be trapped by the sun's gravity, but will continue its journey into interstellar space after its passage. Perihelion. Its closest approach to the Sun occurred between October 29th and 30th, 2025, when it reached a distance of about 203 million kilometers from the Sun, relatively close but safe for its structure. Physical characteristics. Studies have revealed that 3I Atlas has a nucleus of around 20 kilometers in diameter and an estimated mass of more than 33 billion tons, larger than previous interstellar comets like 2I Borisov. Composition and age. Since May 2025, cometary activity has been detected, releasing gas and dust, primarily water and hydroxyl radicals OH. This confirms that its nature is not that of a simple asteroid, but a genuine comet activated by the sublimation of volatile ices different from water. This is consistent with the spectroscopic detection of carbon dioxide, cyanide, and other unique chemical compounds, suggesting an origin in very ancient regions of the Milky Way, having formed approximately 10 billion years ago.
However, anomalies abound. 3I Atlas showed an abrupt increase in brightness before and after perihelion, even emerging with a blue color more intense than the Sun, a rare phenomenon in comets, which usually exhibit a reddish coloration due to dust. It also displays poorly explained dynamic behaviors, such as emitting an anti-tail towards the Sun, and loses mass without evidencing a visible traditional tail, aspects that puzzle researchers. Furthermore, some measurements indicate the presence of unnatural materials, such as nickel alloys, characteristics that fuel debates about its composition and possible provenance. Despite the confusion and alternative theories, the most recent evidence, such as the detection of the OH radio signal, firmly supports the hypothesis of a natural comet, albeit one with unprecedented and surprising characteristics in its behavior and chemical composition. In conclusion, the current scientific consensus is that 3I Atlas is an interstellar comet of exceptional size and composition, providing new clues to understanding the formation and evolution of cosmic objects in the galaxy, though it still leaves important enigmas open. Its study not only expands our knowledge about comets from other stellar systems, but also challenges the frontiers of traditional physics and astronomy, inviting us to stay alert to its next movements. 3I Atlas remains an enigma, a direct window into the oldest secrets of our galaxy and the limits of human knowledge. It is not an ordinary comet, but an interstellar visitor that defies all known rules, revealing with every image and signal a history of origin and nature yet to be discovered. Although science has clarified much of its composition and trajectory, the mystery and concern persist. What more can this invisible traveler teach us? Only time and new eyes on the cosmos will unveil its last secrets. And meanwhile, 3I Atlas continues its course, reminding us that the universe is much stranger and more fascinating than we can imagine.